All right, so for this one here, we've got to figure out how to get this down to the same argument. So here the argument 6 alpha, here it's 2 alpha, there it's 4 alpha, and mixing those up like that, we can't really solve. It's got to be all 6 alphas or all 2 alphas or all 4 alphas or all maybe just alphas. So we got to check out the formulas that we have so far and see what can we do to clean that up a little bit. So here I have a difference of cosines, and we did have a difference formula. And I went on the internet and did a search for trig identities. I came up with this one at Clark University, and there's a ton of pages with trig identities. Like sometimes I go to Purple Math, Wikipedia has a huge number of identities, more than we cover in this class. This one has most of the ones we cover in this class and a few more. So identities we're working on is we have this one right here, which has the angle sum, angle difference, and then sine cosine or cosine cosine. And if I compare that to my problem, right, my problem doesn't quite look like that. So let's keep looking. Other ones we looked at, scrolling down here, were the product to sum and the sum to product. And this over here looks more like what I have. So let's look again. This is a cosine minus a cosine on the left. And then here I have a cosine minus a cosine. So I'm going to grab that identity right there. So it says cosine of alpha minus cosine of beta equals -2 times the sine alpha plus beta over 2, alpha minus beta over 2. And my only objection with their identities is they didn't put parentheses around it consistently like they did here, but not there. That's bad math. All right, so that's our identity right there, negative sine sine. So these are the two angles I have right there. And so their formula, applying it to that, and maybe I'll just rewrite it with, let's see, an x and a y, for example. So they said if you have something like cosine of x minus cosine of y, then that's going to be equal to -2 times the sine of x plus y over 2 times the sine of x minus y over 2. And my x is 6a and my y is 2a or 2 alpha. So then I'm going to get -2 sine of 6 alpha plus 2 alpha over 2 times the sine of 6 alpha minus 2 alpha over 2. So let's see if that helps. -2 sine 6 plus 2 is 8. 8 divided by 2 is 4. So that's going to be 4 alpha. And then here I have 6 minus 2, which is 4 over 2 is 2 alpha. All right, so then we put that back over here. So we cleaned up this part, or we rewrote it. Let's see if it cleans anything up for us in the end. -2 sine of 4 alpha times the sine of 2 alpha equals sine of 4 alpha. All right, so before I had a 6 alpha, a 2 alpha, and a 4 alpha. Now I only have 4 alphas and 2 alphas. So that's a little bit better. And we could apply another identity, but I have an idea. If I bring the sine of 4 alpha over, or bring this all to the other side, let's see, what does it matter? I think I'm going to take this stuff here and add it to the right. So again, I'm just going to add this to both sides. Oops, 2 sine 4 alpha plus, oh, no, times, excuse me. All right, since these aren't exactly like terms, they're kind of complicated, then what I have is I put a 0 on the left side now. And on the right side, I have sine of 4 alpha plus 2 sine 4 alpha times the sine of 2 alpha. And what I was thinking, 2 alpha, there you go, is that I can factor now the sine of 4 alpha out. So if I do that, I get the sine of 4 alpha times, if I factor this whole part out right there, I get a 1. And then here I'm left with the 2 sine of 2 alpha. And I was thinking back in section 1 where we would get a 0 on one side and have a factorable other side. And so I got a factorable other side. And the point there is now I can break it into 2 different problems. So rather than apply another identity to try and change the 4 alphas maybe into a 2 alpha somehow, I just separated them into 2 different problems. One of them is the sine of 4 alpha equals 0. And we'll solve that in a minute. And the other one is 1 plus 2 sine of 2 alpha, there we go, equals 0. All right, so in a lot of trig situations are like this. We get this weird situation. We got to say, okay, what does that most resemble in terms of formulas I know? And then we see if that helps to make it an easier problem. And then, so we got lucky here. All right, so let's see, when does the sine equal 0? So just thinking about the unit circle on that, sine is a y value on the unit circle. So that is here or here, right? So at 0 or pi. So I'm getting 4 alpha could be 0, which means alpha could be 0. And I'm also getting 4 alpha could be pi. So alpha could be pi over 4. And then we could keep revolving around, right? So if I go around once, 2 pi is another answer. Let's see if that works out. So if I said 4 alpha equals 2 pi, then alpha would be 2 pi over 4, which is pi over 2, which is still in the region that they asked about. Could I keep going on that side? So let's see, that's 2 pi. If I keep going around, 3 pi would be another one. And so theta would be 3 pi over 4 is another solution. Whoa, I'm getting a whole bunch here. If we keep going, so we're at 3 pi, that would be 4 pi, 2 revolutions. 4 alpha equals 4 pi, and alpha would be pi. Oh, and we stop there. So this says alpha has to be less than pi, so that one doesn't count. Whoa, so I got 1, 2, 3, 4 solutions just from this side here. Let's look at the other side. So the other part of this equation, switch to green again, we would say subtract 1, then divide by 2. So someone let's switch to green, please. Thank you. Sine of 2 alpha. So I'm going to subtract the 1 and then divide by 2. Negative 1/2. So I'm going to think about that for a sec here. Unit circle. Sine is a y value. Y equals negative 1/2 would be down here. So that would be this angle related to that radius, or angles related to that radius. And this says I have to have positive angles. Okay, so normally I would look at this and I would see that negative pi over 6 there. So I'm going to call that theta instead of alpha. So theta equals negative pi over 6, but I can't use that one. But I could, let's use a color here, I could rotate around to get to that one, which would be pi plus pi over 6, which would be 7 pi over 6. And then I could also go around to get to this other angle in a positive way, which would be 2 pi minus pi over 6. So what would that be? 11 pi over 6. All right, so let's see if either of those work out here. So my angle theta is really 2 alpha. So my claim here is that 2 alpha could be 7 pi over 6. Divide by 2, and I get alpha is 7 pi over 12, which is a little bit bigger than pi over 2, right? Because 6 pi over 12 would be pi over 2. That's inside this region here. All right, so let's see about that one right there. I also believe that the angle 2 alpha could be 11 pi over 6. And so then alpha would be 11 pi over 12. 12 pi over 12 would be pi. So this is just less than that. So I think I have 2 more solutions here. Wow, this was a big one. So I think I have 1, 2, 3, 4, 5, 6 different solutions between 0 and pi. Let's check this on a graph. When we check something like this on a graph, since it's a function equals a function, we graph these two separately. And let's clear all this out. Okay, so what did we have again? We have 6 alpha minus 2 alpha. Okay. Cosine of 6x minus cosine of 2x. Whoa, that's a cool wave. All right, so that's that one. Then we want to compare that to the sine of 4x. Sine of 4x. And we want to find the intersections from 0 to pi. So let's zoom. Pi is around 3. Let's zoom one more time. Okay. So we're looking for the intersections in this region here. So we identified one at 0. So we got that one. The next one happened here, pi over 4. Let's look back at our notes. Yeah, pi over 4 was the next one we found. Cool. Next one happens at pi over 2. Yep, pi over 2 down here. Switch to this down there. Next one here, 7 pi over 12. I believe that came from the other part of this equation. Oh, there's my 7 pi over 12. Boy, this is a pretty good morning. Let's see. I want to see my graph, please. 5 pi over 8. Oh, wait, that's not an intersection. That's a max. Sorry. Go away. There we go. 3 pi over 4. I do remember seeing that one. Oh, there's my 3 pi over 4. And then the last one should be 11 pi over 12. Right here. Oh, no, intersection. Sorry. Where do the two curves meet? Right there. Oh, wow. I think we did it. Those are all the intersections. Where do the red and black meet? There. 1, 2, 3, 4, 5, 6. And that's what we found. Whew. Wow. That was a workout. That was awesome. So we did find all of the solutions. And again, the method here, we had sines and cosines. We had 6 alphas and 2 alphas and 4 alphas. That's way too much to apply. So I recognize the cosine minus the cosine as the difference to product formula. That then reduced this down a little bit. So now that I only had sines to work with, and then I brought everything down and factored and applied the 0 product rule, which meant I could break this into 2 simpler problems. Once I got there, I kind of ignored the 4 alpha for a second and just said, when is the sine equal to 0? Identified those angles, and then I applied those angles to the 4 alpha. Same thing on this side. I recognized the -1/2 on the unit circle for the sine, and then I found some angles that go with that, and then I applied the 2 alpha, and I got my solutions. And that's typically the way I attack these problems in a sequence like that.